Today we're going to start looking at the overflow topic, but we're going to focus on unsigned overflow today. But quickly, we're going to have a quick look at the incrementation of binary numbers, both in signed and unsigned. So you can see that incrementation and decrementation are just the same in both cases. We have the same binary numbers, and we can add one to get to the next position. We can take away one to get to the previous position. It's all very similar in both cases. The thing to get your head around in this one is that the wraparound takes place in different places. So an unsigned wraparound occurs when we go from 15 to 0, because we go over the top, because we don't have enough space to represent 16, and we go over the top to 0. So we wrap around from the end right back to the beginning. Whereas in 2's complement notation, because of the different meaning of the numbers, wraparound occurs somewhere else, because the place which 15 would be is 1, 1, 1, 1, which equals minus 1. If you increment that, you just go to 0, and that's a logical answer. However, wraparound does occur in 2's complement numbers, or signed numbers, when we go from 7 to minus 8. Because when you add 1 to 7, you shouldn't get minus 8 out, but because of the way we structure it, you do get minus 8 out. However, the fact that we can increment and decrement numbers in the same way in both signed and unsigned means that we can do addition identically in both cases. So let's remind ourselves of binary arithmetic. So we have a couple of numbers to add, but first let's just have a look at the rules. Remember that if we do 0 plus 0, that gives us 0. If we have 1 from either number and we add it to 0, that gives us a 1. If we do 1 plus 1, that gives us a carry forward into the next column, and a 0 in the original column, so we get 1, 0. If we do 1 plus 1 plus 1, that gives us a carry forward, but also a 1 in the original column, so we get 1, 1 out. So let's do the arithmetic. If we do 1 plus 0, that gives us a 1 with no carry forward. If we do 1 plus 1, that gives us 0 with a carry forward. And then we have 1 plus 1 plus 0, which gives us 0 carry forward. And then we get a 1 carried forward and a 1 in the original column. 1 plus 0 is 1. And then we don't have a carry forward, so we just do 1 plus 1, which gives us 0 and a carry forward. Then we do 1 plus 1, which gives us 0 to carry forward. And 1 plus 0 is, of course, 1. So there we go. That shouldn't be anything too surprising, but it's good to have in your head a strong understanding of binary arithmetic to tackle overflow, because it can be a bit tricky. So what is overflow? Well, overflow occurs when the correct result of a calculation is too large to fit in the space available for it. So with unsigned, that means we go over the top. We won't worry about signed today. We'll do that in another video. But let's have a look at unsigned overflow. So it occurs if the sum is greater than the maximum possible value. So if we have 4 bits, that'll occur when we add anything to 4 bits where all of the ones are set. If we add anything to that number, it'll take us over the top and we won't get the correct answer. So if we added 2 to 15, we wouldn't get 17, which is the correct answer, because we don't have enough space to store 17, because it carries forward into a column we don't have a bit for. So instead of getting 17 out, we would increment by 1, get to 0, increment by 1 again, and just get 1 out, which is of course not the same as 17. So that's a bit of an issue that we need to worry about when we're using binary numbers. So let's have a look at an example. So here are 2 numbers. They were unsigned. I'm going to refer to them as number 1 and number 2. So the question is, if we add 37 to these, does overflow occur? Well, let's see how we would figure that out. So we have number 1 on the left and we have number 2 on the right. So how do we figure out what if 37 can be added to them without overflow? Well, we figure out what the biggest number that can be added without causing overflow is, and then we see if that number is bigger or less than 37. So how do we figure out what the largest number is? Well, we need to fill in the zeros with 1s. So we just create a binary number with 0s where all the 1s are, but 1 where the 0s are. Like so. So these blue numbers represent the largest number that can be added. So if we put a 1 in any of these other columns, which are 0 in the blue numbers, we'll cause a ripple forward and we'll carry over into the next column. So we can't do that. So we just put 1s where the 0s are, 0s where the 1s are. Kind of the negation. So then we need to say, is 37 bigger than these numbers? Yes, if we add these together we get 1, 1, 1, 1, 1 out. But let's see if 37 is bigger than these numbers. Well, we convert 37 to binary and we see if it's larger than the other 2 numbers. Well, it is larger than this blue number on the left here for number 1, but it's smaller than the blue number on the right for number 2. So we can add it to the number on the left, number 1, and we will get overflow because it's bigger than the largest possible number we could add without causing overflow. So we will cause it if we add 37. If we're on the right, we won't cause overflow because 37 is smaller than the largest possible number we could add to it. So we will still be within the bounds of numbers we can represent. So there we go. Left is overflow, right is no overflow. So if we add 37 to this, we can see this. On the left, we have a carry forward into a column we don't have space for because we only have 8 bits, but we would need 9 bits to represent this number. However, on the right here, we haven't gone over the top, so we don't have a carry over. We just have a number which we can happily represent with 8 bits. So let's see how we would detect this using mips. So, when will addition of two numbers cause overflow? Two numbers being A0 and A1. Well, overflow occurs when A1 or A0 plus A1 is larger than the largest value we can represent. And the largest value we can represent is the number with all of the ones set. So that's a 32-bit number with all of the bits set to 1. So when will this occur? Well, we can rearrange this formula. So we can say that it would mean overflow would occur if A0 was greater than the largest value minus A1. That's just equation rearranging. So we just move A1 over to the other side. It becomes negative, we subtract it from the largest possible value. But because the largest possible value is just the number with all of the ones set, if we subtract A from it, or A1 from it, that's the same as negating A1. So what we need to check is if A0 is greater than the negation of A1. So that's what we do in MIPS. We do the negation of A1, we store that in T0, and then we set it to see if we set greater than unsigned, because we're using unsigned numbers, to see if A0 is greater than A1 minus the largest value, or taken away from the largest value, which is the same as the negation, which is in T0. So we just check to see is A0 greater than the negation of A1, and if so, we set the flag. So that's all you would do. It's relatively straightforward for unsigned numbers. You can think a little bit about when does subtraction cause overflow. And you'll need to think about that a little bit. I'll leave that as an exercise. But you should find out that it comes down to when A0 is less than A1. So that's everything I wanted to cover today. I hope you found this useful. If you have any questions about anything we've covered here today, please do let me know. Thanks.